Okay, so let's continue down the chain. So we've just got a null with agent definition, if in case you want to refer to the agent created, and then we got this this SOP that side effects are put together for saving a cache, which saves everything. So we got the rig, agent layers, shapes, clips, transform groups, puts everything together in a handy thing here. And inside we just got this ROP network, which, you know, you don't need to worry about it. It's kind of all the hard work is done for you now, which is really nice. So if you've got lots of clips, if you've got a really heavy geometry, it can be useful. It's not always necessary. So you can just click save to disk, and then if you go into the folder there, if I bring this over, you can see it makes this agent folder, new one, and inside we've got mocap biped 3, which is the name. Okay, let's find that, and then inside we've got all the info we need. Great, and then we can check load from disk, and that will be, well, in our case, probably about, when we haven't got much going on, but should be faster if you've got lots going on there. And then agent prep. So here, this is what we use to tell Houdini which parts of our rig are what, right? So, for example, this is all filled in for us because we've used the mocap biped 3. So if you use another rig, then the part which represents the toe will have a different name. Okay, so for certain effects, like, well, with the legs, the typical one would be adjusting to terrain, right? So if our agent is walking over uneven terrain, we want the feet and the legs to adjust and bend according to that terrain. And to do that, the solver needs to know, okay, which part of the rig is the toe, because the name might be different, right? Which part is the ankle, the knee, and all this is filled out for us because, as I said, we're using this, right? That's added a 5 there, get rid of that. So you can see that in the presets, we've got all these set up already. So yeah, the legs can be used for terrain and for foot locking as well, which we will have a look at later. We can do something called look at as well, which uses the head and spine. So you can say, I want all of my agents, no matter where they're running, to look over at something interesting. So maybe there's, a big fire and everybody's running away, and we want all of the agents to turn their neck and head to look at that. So again, depending on your rig, the name of your hips might be something else, and so forth. Okay, so that's all good and ready to go. So now we can use if we come back out, I'm gonna hide that also. So that's our agent ready to go. Now we've only got the one agent there, so let's add more. So if we come up to the shelf tool again and go to populate, to check that, it's asking us to select the terrain, which we don't have. So we just press enter, and there we go. We got a whole load of agents there already. So this is giving me another geo here with these chain of nodes inside. Okay, so basically we got an object merge grabbing the out from the setup that we just made. Okay, so from here we're jumping into our crowdsource here. So you can have multiples there. Okay, so we could have more than one agent, different characters, have more than one out, and connect them up to this object merge and bring them into the crowdsource. Okay, so the crowdsource, you can think of it as like a copy to points. Basically, we're scattering points, or taking an input of points and then placing one agent at each of those. Okay, and now they're all identical. They're all at the same time, the same clip animation, the same scale. We can use this to vary all of those. We have control, inside if you just want to have a square, a rectangle of agents, we can change this to a formation, so it's more like a military kind of, or parade kind of thing. You can do random, so obviously you can change the area size, whatever you need. Change the number of agents, relax, okay, which you might recognize from the scatter SOP. What else? You can use density, so you can plug in a geometry with a density attribute and use that. And then we can randomize everything. So we've only got the one agent, so we can't randomize that. Initial states, so we do have two. Okay, we've got a walk and a run. So there we can see some, let's see, some of them are walking and some are ready to run. Okay, we can, the clip time, we can randomize that. Okay, so now we're starting to get a difference between each of our agents. The layers, we don't have any layers. Scale, we can change that. It's a bit over the top, but who cares? You know, you can, the overall scale you can change, and how much randomness there is. Okay, I'm just doing this for demonstration now, so I'm not really tweaking it to anything realistic. And the velocity heading and the up vector as well. You know, if you want, you can, let's say you are simulating like insects, you could have like lizards crawling on walls or something. You'd need to change the up vector then, because up for them would be, you know, depending on the walls, or you know, flies on the ceiling or something like that. Great. And then here underneath we've got an agent constraint network, which for us in this case now is not doing anything. So this is for setting up your ragdoll effects, which we don't have at the moment. And so the constraints will come out here, and we won't have any constraints, right? And then here this is coming out and ready to simulate. So let's do that. Let's set up a simulation. So I'm going to come out again, select this, come to simulate. Now it's asking us which states to add. So we've got a run and a walk. We don't have any ragdoll going on, so we'll leave that. Click accept. And there we go. We've got our DOP network. Let's dive inside and see what we've got. So we've got a whole load of nodes. And to be honest, right now, we don't need most of them. So all of this is our constraint network for ragdoll, which we don't have. So I'm just going to delete that. Okay. We have a static solver also obviously for the ragdoll simulation. We've got a bullet solver for a ragdoll simulation. Don't need that. Multi-solver. Don't need that. Okay, now we've lost because our crowd object has been disconnected. Gravity, merge, we don't need any of this. We can just connect our output right up to here. And our crowd object into our crowd solver. And there we go, we got everything back. Delete all these. And let's press play, see if we actually get something. Going to turn off the point visualization. It's a bit distracting. And there we go. Got our guys walking along. So you can see a problem there already. If you watch the feet, they're kind of slipping around, which is no good. Okay, so what I'm going to do is come up here to the states. Bring that over. And as I said before, I always use locomotion, and yeah, I can't think of a time when you wouldn't use that. So now we've got these guys walking along, and their feet are sticking to the floor correctly. Okay, and you can see they're kind of spreading out. They got a bit of a random movement, and that's because of the avoidance, which is on by default. So they're trying to stay away from each other. Doesn't work everywhere. You can see them intersecting there. but they're all trying to kind of get away from each other, you know. Right, so here we've got our crowd object. So that's the same as the object in any simulation, just like your bullet object or pop object or whatever. We've got, in fact, this is very similar, I think, to, no, it's not. Yeah, it's very similar. So all of this you'll recognize is the same as in an RBD simulation, physical parts here as well for ragdolls. And then here we can bring in more information, which we're not going to do now. Maybe later we will use that. Then we've got a source, which is, as you can see, a pop source. Just bringing in our crowd agents. But we don't actually need that. So I can take that, delete the source, and we can actually just use the crowd object as a source, right? You only need the pop source or the crowd source when you're using a multi-solver. So, and that still works there. So here we got transitions. So transitions are, so let's say we want to change from the run to the walk. We could do that real quick, why not? So, you know, I'm going through this quite quickly just as a quick introduction, but we'll be coming back to these again in more detail, okay? So don't worry if I don't explain absolutely everything. So we need a trigger, and a trigger will tell me when to change from one animation to another. So I'm going to use, we've got lots of different things. We've got object bound by default. Let's just use time. So when the time is more than, yeah, we'll do 10 frames with an offset of nothing. We will transition, okay, when this is true, we will transition from, by default we got it correct, from walk to run, okay? So let's see if we can find somebody who is walking. This guy, I think. And let's see if we can see that transition. There we go, see, and now they're all hopping. Great, so I'll leave it there just for now for a really basic introduction to the crowd sim. Next we're going to move on and bring in our own geometry and dive into this a bit more deeply.